Hello. Today we're going to do 5.8 quadratic inequalities in Honors Algebra 2. When graphing quadratic inequalities, we have to pay attention to a few things. Should the function's boundary be solid or dashed? Well, if it's less than or greater than, then it's going to be dashed. If it's less than or equal to or greater than or equal to, it should be solid. How do we graph that particular quadratic function? Well, that'll depend on whether it's in vertex form, standard form, etc., or factored form. Then you get it graphed, and where do we shade? Do we say shade inside the curve, outside the curve? Well, when we do that, to decide that, we're going to test a point that is convenient into the equation and figure out where we should shade, whether it makes the inequality true or not. So these are the things you have to think about as you're doing these problems. So let's try one. First, we're going to graph this inequality. Our first step would be to use the fact that x equals the opposite of b over 2 times a, which is the axis of symmetry. So we've got an a of 1, a b of -8. So x equals the opposite of b will be 8 over 2 times a, which is 2 times 1. So we get x equals 4. So that gives us a vertex at 4 something and an axis of symmetry at x equals 4. If we substitute 4 back into the inequality, or just into the equation, we're going to want to evaluate 4 squared minus 8 times 4 plus 17. Now that's 16 minus 32, which would be -16, plus 17, which is 1. So our vertex is at 4, 1. So we plot that, and then we can just do the 1 squared, 2 squared method. Now before we do graph the parabola, we want to decide based on the inequality symbol whether our parabola should be dashed or solid. Since it says greater than, it should be dashed. Okay, so you're not actually going to graph the parabola solid. You're going to dash the whole entire thing. So let's go ahead and 4, 1, we've got our vertex plotted. If we do the 1 squared, 2 squared method, a is 1 here, so we're going to go up 1, right 1, up 1, left 1. 2 squared is 4. From the vertex, go up 1, 2, 3, 4, right 2, and left 2 from the axis of symmetry. Now, I'm going to just dash a line to graph the parabola. Now we're trying to graph either in the interior of the parabola or on the exterior of the parabola. So we have to decide where to shade. Now the easiest point to test is going to be 0, 0, since it's not on the parabola. So we're going to test the point 0, 0. If we plug in 0 in for y, we want to check if it's greater than, which is the symbol in the inequality, to 0 squared minus 8 times 0, that's going to be 0, plus 17. Is 0 greater than 17? Well, because this is false, then we're not going to shade where the 0, 0 is. We're going to shade on the inside. So all of these points on the interior of the parabola satisfy this inequality. Okay, number 2, another example. Let's go ahead and, since this is in standard form, we're going to do the x equals the opposite of b would be -6 over 2 times a would be 2, which gives us an x value of -3. So we got a vertex at -3 something. Substituting -3 back in here to get the y value, we're going to have 9, -3 squared is 9, minus 6 times -3 would be 18, plus 4. That is -9 plus 4, which is -5. Okay, so we've got a vertex at -13. Now, because this has got a bar underneath, which reads less than or equal to, we're going to need to make a solid line parabola. Okay, so our parabola is going to be just like normally graphed. And then we're going to decide what side to shade on. So we're going to go to -3, -5. We'll do the 1 squared, 2 squared method, up 1, right 1, up 1, left 1. Since a is 1, up 1, 2, 3, 4, right 2. Wait, this graph is tiny. Left 2. I'm going to sketch the parabola. It is solid, so I just do a normal sketch. If I put in 0, I'd get 4. Okay. Not such a big concern. Now, I can see that 0, 0 is not on the parabola. Its y-intercept is actually at 4. So I'm going to test 0, 0 again. Okay, so I'm plugging in 0 for y. I want to see if it's less than putting in 0, less than 4. Now, that is a true statement. When you plug it in, 0 is less than 4. So therefore, we will shade outside where 0, 0 is. Okay. Next one. Opposite of b would be negative 2. Over 2 times a is 2. We get x is negative 1. So our vertex is at negative 1 something. Plug it in. Negative 1 squared is 1. 2 times negative 1 will be minus 2 plus 2. I get 1, 1. Negative 1, 1, excuse me, for my vertex. Okay, again, it's got an a value of 1, so up 1, right 1, up 1, left 1. Or up 1, 2, 3, 4, right 2, and up 4, left 2 from the vertex. Oh my gosh, it's getting so hard for me to see just because, oh, this is solid because of the bar underneath the inequality symbol. I went too far on that one. There we go. Okay, now that's really close to 0, 0, but it is not actually hitting 0, 0. I kind of missed my graph. So we can still test 0, 0. It's just the easiest point to test because when you plug it in, you can do it quickly. Is 0 greater than or equal to 2? No, it's not. So since this is false, we're going to shade where 0, 0 is not. It's outside the parabola, so we'll need to shade inside. Okay, it made it false, so we do not shade where 0, 0 is, which is outside of the parabola. Over here, it was true. 0, 0 was outside the parabola, so we shaded the outside. On this one, 0, 0 was false, so we did not shade where 0, 0 was. We shaded inside. Okay, not sure where the other problems went. So I'm going to pause a moment because I want to do a few more with you. Okay, I popped in these now into the Smart. This one is opening down because we have a negative a value. I'm still going to go through the same process. This is going to be dashed because it's less than. And I'm going to do the opposite of b, which would be negative 4 over 2 times a. And this times a is negative 1. So we got negative 4 divided by negative 2. And that's 2. So our vertex is going to be at 2 something. Plugging in 2 into the equation will give me the opposite of 2 squared, which would be negative 4, plus 4 times 2 would be 8, minus 6. Okay, so that's going to be 4 minus 6. We're going to get negative 2. Okay, so we go to 2, negative 2. Our a value, again, is negative 1. So if we're going to do the 1 squared, 2 squared method, we do negative 1 times 1 squared. That means we're going to go down 1, right 1, and down 1, left 1 from the vertex. And then negative 1 times 2 squared would be down 4 from the vertex. 1, 2, 3, 4, and right 2, and 4, left 2. It's dashed, so we need to make sure we show a dashed parabola because it's not including the parabola. That's your boundary line. And now we get to determine where to shade. So I'm going to test, again, 0, 0. If I put in 0 for y, I get 0 is less than. If I put in 0 for x, I get negative 6. 0 is not less than negative 6. That is false. So we do not shade where 0, 0 is. We shade in between the parabola, underneath the parabola. Okay, now another way to look at this, you may notice that when it's less than, it's underneath the graph, and when it's greater than, it's above the graph. That's another way to think of it. Maybe some of you noticed that. But I'm going to continue doing it by testing a point. So I'm going to do the opposite of b would be negative 4 over 2 times 2 this time. That's equal to negative 1. So my vertex is at negative 1 something. If I put in negative 1, I get, I don't know what that's doing there. It is recording. Okay. If I put in -1, I'm going to get a y value of, let's see, 2 times -1 squared would be 1. And then 4 times -1 would be -4. 2 minus 4 would be -2. So -1, -2 is my vertex. This time the a value is 2, so we have to do 2 times 1 squared if we do the 1 squared, 2 squared method. And that would be 2. So we have to go up 2 from the vertex, right 1, up 2, left 1. This one's a skinnier parabola. And 2 times 2 squared would be 2 times 4, which is 8. So from the vertex, we can go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And right 2. Up the axis of symmetry and over 2. Okay. Sketch it. This one is, solid because it has an inequality symbol that says greater than or equal to. So it includes the boundary of the parabola. So that's what we graph. And then we pick a point. This one looks like it went right through 0, 0. It did. So we have to test something other than that to determine. I'm suspecting that it's shaded in between, and that's because it says greater than. So it's probably above the graph. So let's test another point. So I'm going to pick the point outside the parabola. Unless you want to pick one inside, I'm picking 2, 0. Okay, so I'm testing 2, 0, and it's just a random point I picked outside of the parabola. So if I put in a 2 for x and a 0 for y, I would get 0 is greater than or equal to 2 times 2 squared would be 8, plus 4 times 2 would be 8. 8 plus 8 is 16. 0 is not bigger than 16. So this is false on the outside of the parabola. So, yep, we shade on the interior. Okay, and this last one, the opposite of b would be 4 over 2 times -2. That's -4. And that gives me an x value of -1. So my vertex is at -1 something. If I plug in that, I get 2 times -1 squared would be 1, plus 4. If I put a -1, I get plus 4, plus 2. That's -2, plus those cancel out. I get 4. Anyway, you guys know how to do that, so I'm going kind of quick now. -1, 4 is the vertex. The parabola is opening down, and it's dashed because there's no the inequality is greater than only, not including. So I'm going to go and do -2 times 1 squared, which would be down 2 right 1, down 2 left 1. And if I do -2 times 2 squared, that's going to be down 8. 2, 4, 6, 8, right 2, and left 2. Dash the parabola. Okay. And then test a point on the interior or exterior. This says a greater than, so I'm thinking it's going to be above the parabola. So I'm going to test 0, 0 because it's not on the parabola. If I put in 0, I get 0 is bigger than 2 because these would cancel right out. 0 is bigger than 2, that's not true. So I'm not going to shade where the 0, 0 point is. It's on the inside of the parabola, so now I have to shade on the outside. Okay, that's your examples for that. Next, 7, it says write a quadratic inequality for each graph in vertex form. So we find the vertex. This has a vertex at 3, 0. Vertex form is y equals a times x minus h quantity squared plus k. This thing says to fix the scale on number 8. I'll fix it for you momentarily. We do have a point on the parabola right up here at, well, 3, 0 is our vertex. So y is something, and then I'm gonna put the inequality in second. It will be x minus 3 quantity squared. This thing's going up 1, right 1, or up 1, 2, 3, 4, right 2, so it has an a value of 1. And it's shaded above the graph, and it's solid, so I'm going to call this a greater than or equal to. All right, the a value is 1 because it went up 1, right 1 to get to the first points. See right there, up 1, left 1, or up 4, right 2. Okay, so that's why a was 1. The second one, we're going to need to think about these points. I see a scale. This goes 6, then 12, 18, then 24, then 24, 30, then 36. So I don't know what that 12 is doing there, so just get rid of that 36. So the point -2, 36 is actually the vertex. All right, so I know how to fill in part of this. I would have x plus 2 quantity squared plus 36 on the outside. This thing's opening down. Okay, so in order to test and check, I have that vertex of -2, 36. Another point on here I can see is right here. That is 4, 0. So I'm going to take this format right here, and for y, I'm going to put in a 0. I'm going to try to figure out a, so I have to leave a in the equation. I'm going to put in 4 for an x value, and then it was x plus 2 quantity squared, and then plus 36. In order to solve this, I would subtract 36. I'm solving for a. 4 plus 2 is 6. 6 squared is 36. Oh, if I divide by 36, I get -1 for my a value. So this is -1 in front of here, or you can put a -1 if you want to write it. I'm just going to put the negative sign. And then since it's shaded underneath, it's be a less than. The graph is a solid line, so it's or equal to. Okay, solving, we have two methods for solving quadratic inequalities, graphically or algebraically. So graph the quadratic and identify the areas where the function is above or below the x-axis. All right, so in order to do this one, we could either complete the square and find the vertex, or we could factor it. I'm going to factor it, x minus 5 times x minus 1, which would give me x-intercepts of 5 and 1. You set those each to 0 to get those. So 5 is one of the points. This is a less than, so they're not actually included. They are actually, it's going to be dashed. Okay, so oops. This is dashed. My pen got stuck there for a second. And 1 is the other. Now, in order to find the vertex, we can add those two x-intercepts and divide by 2. So 6 divided by 2 puts me halfway at x equals 3. So the axis of symmetry, or vertex, is at 3 something. You can plug 3 back in here. That would give you 9 minus 18 plus 5. So that's -9 plus 5, which is -4. So 3, -4 would be the vertex. Not that that is actually really the big deal. So I'm going to go ahead and show you where this parabola is. We've got 3 points already, and it is dashed. So we're going to dash it. So which means that the vertex is not included, nor are those x-intercepts. Okay. Now, if I test 0, 0, I would put in 0 for x. Is 0 less than 0? Well, that doesn't work, does it? So what we got to do is test a point in the interval. This is going to be either tails, or just like when we did our inequalities before, you're either going to be shading between or outside. So as far as an interval goes, where is this true? Well, this is not set up like the other one, so you can't go with the arrow. So inside here, I could test the point 3, because 3 is in between 1 and 5. So if I stick 3 in there, I get 9 minus 6 times 3 is 18 plus 5, and I want to see if that's less than 0. So I'm just testing a point to see where it's true. I could have put in 0, which would give me 5 is less than 0, which is false. So we wouldn't shade out here, we would shade inside, but I'm just showing you could test something in between the interval here. So put 3 in, you would actually get something that is true, because 9 minus 18 is -9, plus 5 would be -4, which is less than 0. So I know it's true inside here. So we're going to shade on the inside. Now, as far as an interval notation, all we're going to use is the x values that are making this true. Everything between 1 and 5 and not including 1 or 5. So that's our interval notation for the solution. It's between 1 and 5. This next one, believe we can graph that one too. 2x, let's see, we got to get a -5, so we're going to need a -3 and a +1 over here. Okay, so I'm going to set those to 0 and solve them. X is 3, and this one's going to give us x is -1/2. Okay, so this is greater than or equal to, so this would be solid. Okay. The vertex is going to be gross on this one. -1/2 is here, 3 is there. If we take -1/2 plus 3, that's 2.5, and we divide that by 2, that's 1.25, which is 1 1/4. So our vertex for this one is actually at 5/4, gross, 1 1/4, and then if I plug in 5/4, I'm just going to tell you that what you would get once you got through calculating that is -49/8. Now, this really doesn't matter too much because we know this parabola is going to open up, and we're really just interested in getting the interval. So I'm kind of happy with you just thinking, all right, where are those approximately? -49, that's like a little bit more than -6. So it's somewhere around here. Okay, so you got this parabola. We're going to test 0 in here. -3 is greater than or equal to 0. That is false. -3 is not bigger than 0, so we won't shade inside. We'll shade outside. But all we're really interested in is this interval that we just found out. That's actually going from -infinity up to our -1/2. It included the -1/2 because we had a greater than or equal to, so that's going to be a solid bracket. And we union that with the other side, which is from 3 to infinity. So that's the interval notation for that. Okay, and find the zeros of the function, then test the zeros on the number line. Now I'm going to do it without a graph. I'm just going to do it with factoring. And then finding the two zeros, if you will. I'm not saying these are solutions. These are just boundary numbers. So -2, it's either between -2 and 4, or it's from -infinity up to -2 and from 4 to infinity. So I'm thinking let's test something in the middle. Since 0 is between -2 and 4, I'm going to test 0 in for x. Putting in 0 gives me -8 is greater than 0. That is false. Therefore, I will not shade where the 0 is, which is between them, and it does not include the boundary numbers because of the greater than. So these are going to be curved that way, and we're including the arrows, so I'm showing the graph. And the interval, -infinity up to -2, non-inclusive, union with 4 to infinity and non-inclusive of either 4 or infinity. Okay, 12. Another chance to factor here. 3x and x. I need a 2 and a 1. So they're both addition. Okay, so I factored this. I get a 0 of -1/3 from that one and a -2 from this one. We've done this so many times. -2 is smaller than -1/3. 0 is not in there, between there, but I'm still going to test it. So if I test 0 and I put it in here, I'm going to get 2 is less than or equal to 0. Well, that's not true. Okay, so remember our less thans or equal tos were in between and our greater thans were tails generally. That's why it's in between. And it includes them. So this would be graphically what we get. So that'd be like graphing the parabola and shading on the inside of it. And this would be from -2 to -1/3 as an interval with hard brackets on both sides. Okay, solve each inequality algebraically, answer interval notations. This is something a blast from the past, but this one gives us x minus 9 times x minus 9. Well, that only gives us one answer of 9. That means the only solution is 9. Okay, there isn't an interval. It is the solution set 9 alone. Okay, that bounces off the x-axis. So the only number that satisfies this inequality is the number 9. Remember how that would look? It would bounce, the vertex would be bouncing off the x-axis, opening up. Okay, this one we can first divide everything by 2, which would give you 2x squared plus 6x plus 5 is less than or equal to 0. And then let's see about factoring this thing. It does not factor. Yuck. Okay, which means we'd have to do the quadratic formula. The opposite of b, plus or minus the square root of b squared would be 36, minus 4 times a is 2 times c is 5, all over 2a. 2 times 2 would be 4. We get negative 6 plus or minus 36. Let's see, that's going to be minus 40, and we get negative 4. Uh-oh. Well, I just found out my solutions are 2 imaginaries, which means this parabola does not cross the x-axis. Therefore, there is no solution to this inequality. If you get an imaginary, there's no solution because it doesn't have any x-intercepts. Okay, and 15, I would multiply the entire equation by negative 1. And that, oops, got to change all the signs here. That is going to turn around the inequality symbol also. So I flip that around, greater than 0 now. And then I factor this x, let's see, going to be minus 5, x plus 3. I get x is 5 for one boundary number, and x is negative 3 for the other. Okay, and then I check for anything I plug in here. No matter what I do, I'm going to get a number bigger than 0. Think 5 and negative 3. So this one's actually going to be any solution works. Okay, anything I'm going to plug in here is this is going to be, let's see, 5 and negative 3. If I test something between there, if I put in 0, oh, wait a minute. Now, if I put in 0, I would get negative 15 is less than 0. That's still true. Okay, if I put in, say, a negative number, these all work, because I tested 0 in the original equation. If I put in negative 4, I would get negative 16 minus 8 minus 15. Now, that's all going to be negative. That's going to be less than 0. So anything over here is true. And if I put in a number like 6, I'd have negative 36 plus 12 minus 15. That's going to be negative, so all of these work. So this is any solution. Okay, or infinitely many solutions. All right, now you're going to get a worksheet that I did add all the problems from the textbook to for your homework. So we'll pass that out now for pages 315 to 318. So that's going to replace your worksheet number 28 that you actually already have in your packet. Thank you. Timer time out.